explain the vitamin D thing and sun angles and just a website to hopefully inspire you and make you feel a little bit more summery as such. So this is a website, timeanddate.com. It's got some kind of cool stuff on here and some stuff that you just go like, that's really weird and boring. Like, why would you even look at any of that sort of stuff? All sorts of things on here. Like, you can work out all kinds of stuff. But anyway, what I was going to show you on here is the sun angles and why it matters. So if you look at, you look at all sorts of things like meteors and things like that if you want to, but I'm not suggesting you would do. So if you look at, so sunrise and sunset, why are we not on that? Oh, yeah, okay, so London. We'll use London just as an example. It's about 51 degrees north. And for most people in the UK, it won't be much different than that. If you're in the United States, it will be different. If you're in Canada, probably be fairly similar. And if you're somewhere else, it'll be different again. So I just thought I'd just have a look. So what this is showing you, I won't go into like all the geeky stuff, but this tells you like the actual angle of the sun, the altitude of the sun right now. So right now the sun is 23 degrees below the horizon, right? Okay, and it's showing when the next equinox. So equi just Latin for equal, and nox night again is the March. So that's when you would have a day length of 12 hours, right? So it could be because a day is 24 hours, so a day length would be 24 hours, and a night length would be 24 hours. So it's equal nighttime and daytime. So at the moment we're at 10 to. Now here's the thing. This is what's quite interesting about this. To some extent, why this is a bit skewed is because the clocks change. Yeah, that's why it looks better. It doesn't look normal. But if you have a look down here, so what date are we on? On the 15th, aren't we? Yeah. So we look on the 15th of February. What you can see, so there's some information here, so I'll bring it up so it lines up with this. So the sun rose in London today, but it'll be pretty similar where you are. You can look, if you go on your phone, look it up, you'll see it's probably within, even if you're in far west of the UK, it'd probably be only 10 minutes later than that. So it rose at about 7:15 this morning, and it set at about 5:15. Right. Now, here's the interesting thing, day length. See the difference? 3 minutes 44 seconds. Right, don't worry about the other bits here. And here's the thing. So it's when the sun rises, see it comes up. See the altitude on the right hand side, this one? See the altitude? When that sunrise, it hits 0. That's sunrise. And then solar noon, when the sun is as high as it can be in the sky for that day, is there. So it's 12:14 it's showing. 26 degrees, that's as high as it gets, 26 degrees. That's not very high at all. And then it goes like that. Right? Now, 3 minutes 44. Do you notice that the difference gets longer? Yeah, so our day length gets longer, right? So this is interesting. It's because it's a sine wave. So what's happening is it's getting longer, and it will get longer until we reach that equinox, which is the 20th of March. So if you look, see the day length is getting longer. So not only are we getting longer, but it's also getting longer by a larger amount of time as well. This would be, you could work in it, I'm not going to go through the equations for that. So when you look at this, see the peak for it is actually almost 4 minutes. Right? Now, if you go back to, let's say January, right? Here's the thing with January. Look at this, only a minute longer. So now it's 3 minutes, well over 3 minutes, well over 3 times longer. And that's what this is why January and December feel awful. So if we start to go to March and we start to look at, let's say, times. Now, remember what I've said, sun needs to be about 35 degrees really for you to get any vitamin D. Is that it? No, not quite. So let's try the 15th of March. Yeah, that's about right. So 15th of March, look at the sun altitude. So between 11 a.m. and 1 p.m, that's when you can get vitamin D. Really not hardly anything. So only between those 2 hours. So you go out and take your dog out for a walk, or you do whatever, probably school run by then, maybe, we'll see. Or whatever it might be. We'll just go for a walk. You're not going to get any vitamin D. Why? Because the sun angle is so low. And the same in the early evening. Whereas if you contrast that, and we look at June on here, which is where the longest day occurs, which is round about here. Do you see the difference in the time? Do you see there only 6 seconds, then it starts to get shorter? Look here. The sun angle, where you start to get vitamin D, is by 9 a.m., right? So you can get vitamin D from 9 a.m. all the way through until 5 p.m. I'm gone 5 p.m. At midday, that sun altitude is really high, 60 degrees. Now that's pretty good. Now, the point I'm making here is that you're not going to get vitamin D from the sun really in March. Only if you went out for those 2 hours every single day. And even then you'd need to be pretty much near naked, and that's probably not a good idea in the UK. For several reasons, not just the temperature, but it may also... it's just probably not socially acceptable. Although if you've got a large garden, maybe go for it. But the point is, it's really only it starts to get going in April, and so on. And the interesting thing about this, if you start to look at somewhere that's much nearer the equator, let's say Dakar in Senegal, for example, and you started to look there, where they are, so on the 15th, do you see the sun there, even now in February, is as high as it ever gets here? Yeah? So that's the interesting thing with this. So where you live makes a huge difference. So you see, we all started, I know this comes across as somewhat controversial, but we all started off our lives, or our ancestors' lives, in Africa. And we used to run around basically in tribes, pretty much naked and do our stuff. But now we don't do that. We don't run around and we wear loads of clothes and we don't do loads of stuff. So it causes problems. But look at June, right? Look at this. So let's look at around middle of June. Look how high the sun gets here. 80 degrees. It's almost directly above you. Yeah. And the day length doesn't actually change that much. And that's because it's near the equator. Do you notice throughout the year, it doesn't really get that much. Do you see the difference between day and night length? There's not very much a difference in the colours, the light blue and the very dark blue. Whereas if you were to compare that to, say, I can never spell it, Reykjavik in Iceland, right? Look at this. Hugely different because it's way further north. So in Iceland at the moment, you can forget it. You can forget getting vitamin D from the sun. And that's why, so what's tried to happen over time through evolution, you can punch in wherever you live if you want to have a look at this. You might find it interesting, you might not. But the point here is, through evolution, people who live at more northerly latitudes have ended up with lighter skin so that they can absorb more vitamin D. The problem is, it doesn't work. Which is why we see these problems that we do as a result of lack of vitamin D. But anyway, I just wanted to record this because I thought it might be a little bit inspirational for you. You might just go, oh yeah, the days start to get longer, and they start to get longer more quickly as well. So before you know it, the clocks will go forward as well in about a month's time, and the days are getting longer by almost 4 minutes every day as well. So it's not only are they getting longer, but they're getting longer by more time as well. So that's a really important thing to understand. Yeah, hopefully you found that useful.